Hi guys. Today we'll be doing lecture 22, which is on circles, ellipse, parabolas, and hyperbolas. You probably did it in yesterday's recitation. All right, this stuff was supposed to be taught before that recitation, but because of we have the schedule change for this semester, they kind of have a misalignment. So uh, you had the recitation before this lecture, so you probably have no idea where to start for the recitation worksheets. All right. Hopefully you will get some good grabs after today's lecture, so that you can finish your recitation worksheet if you haven't done so yesterday. All right. Um, but okay. By the way, you guys, can you guys hear me? Do I have audio? Okay, good, very good. Okay. So a little bit of a review is the distance formula. Um, this is probably you have been familiar with how you calculate the distance between 2 points. Okay, so if you have 1 point x1 y1, the other one x2 y2, then distance is the square root of the square of the x difference plus the square of the y difference. Okay, so for example, if you have 2 points, one is minus 5 1, the other one is 7 minus 4, the distance is square root of 7 minus 5. So in this case, I put this is x1, and this is y1, this is x2, and this is y2. Okay. So you just plug it in, numbers here. All right. After that, you just need to simplify this expression. 7 minus 5 is 12. There's a square here. 12 square. Minus 4 and minus 1, you get minus 5. So minus 5 square. And you should get 13 at the end. Okay. So far, so good. Now, the circle in a xy plane, or means that you have a collection of points such that the distance between the point and the center is fixed. So for example, if this is the center, and this is the circle, that means the distance from this point to the center, d1, and distance between the center at this point, we put it d2, kind of hard to see. these two distances should be the same, and the same as the center to this point, center to this point here, all the points around the circle. So this is called the center, and this fixed distance is called the radius. That's what the center and radius mean. All right, how do we represent the coordinates of the points on the circle is governed by this equation. As long as the x and y satisfy this equation, then the point is on the circle. Okay, so this is called the standard form. Sometimes you don't have the standard form to start with, or you have the equation with some x squared, some y squared, some x, some y's. This is not in the standard form. In order for you to get the information like center, like radius, you need to convert it to standard form. Right? How do we do that? For example, like this one, x squared plus y squared minus 10x plus 6y minus 15 equal to 0. This is not a standard form. How do we convert it to standard form? First, you grouped the x terms together and the y term together. So we have y squared plus 6y. And you put the number on the other side of the equation. So on the left, you have minus 15, so you plus 15 on both sides of the equation. Right, so on the left, you have 0, on the right, you have 15. So far, so good? Okay. Now, for x term, what you need to do is complete the square for x. All right. So in this case, remember how you complete the square is if you have a square. Sorry. You have ax squared plus bx. What you need to do here is that becomes the square you need to complete looks like this, right? But you're adding some more things, so you have to subtract this number. All right. So in this case, our b is minus 10, the a is 1. So the square we are completing has x minus 5 inside. Okay, but if you're completing this square, you are adding 25, right? So we need to subtract 25 so that everything is in balance. You don't add or subtract some extra stuff. Okay, same thing here, y squared plus 6y. If you are completing the square for y, the thing inside has 6 divided by 2, which is 3. Okay, but when you complete the square here, you are adding 9. this is something extra, so you have to subtract 9 so that everything is in balance. And the right hand side is still 15, you don't change anything. So far so good. And the next step, the final step, is to put every number to the other side of the equation. So if you have 25, minus 25 here, so you just add 25 on both sides of the equation. You have minus 9 here, so you add 9 on both sides of the equation. This got cancelled, this got cancelled. 15 plus 25 plus 9, you have 49 on the other side of the equation. And on the left, you have x minus 5 squared plus y plus 3 squared. All right, so this is the standard form. So with the standard form, you can have the center and you can have the radius. Right? So the center here, x minus 5, so the h is 5. Y plus 3 means y minus 3, so 5 and minus 3. So this is the center. And the radius, the square of the radius is 49, so the radius is square root of 49, which is 7. Okay. Well, for the first one, you are already having a center form, so the center is 3n minus 5 with the radius 3. Okay. As for the second one, you have the information of the center and the radius, and you want to have the equation. So you just work it backward. Right? So for the standard form, for the the x term is x minus 1 square plus y minus 0 square equals to the square of the radius, which is square root of 6, 36. Right. Simplify this, you can have x plus 1 square plus y square equals to 36. Any questions? All right, so that's everything for the circles. So for circles, the points have fixed distance to the center, but for the next subject we are studying, ellipse, they are not having the fixed distance from the center, but they kind of look like a circle, right? So it looks like you have a circle that is flattened, uh, like an egg. Right? So you have a kind of a slimmer uh, region and a elongate region. So the graph of an ellipse looks something like this. Right? So in this case, at here you have a shorter axis, and in here you have a longer axis. Instead of a circle, you just have the fixed axis, right? Because the radius is fixed. So in this case, we call it the major axis. So this case here is called major axis. And in here, you call it minor axis. So how do we represent a ellipse is the equation here. Okay, oops. So notice it's quite similar to what we have in circle, but instead, remember in circle, well, in this case, it's centered at the origin, so you have -0. So I can just write x squared plus y squared equals to radius r squared. If you just divide r squared on both sides of the equation, you have x squared over r squared plus y squared over r squared equals to 1. So the only difference between a circle and ellipse is that you are dividing different number for x squared and y squared. Right? For circle, you're all dividing by the same number, r squared. But for ellipse, you have an a squared and b squared. Right? Where a is bigger number and b is a smaller number. Right? So in this case, when you're dividing a larger number for x, then the major axis happens on the x-axis. And to the opposite, then the minor axis happen on the y-axis. Okay. And for ellipse, it has a actual term which is called the foci. You have two foci. One focus is on the left side of the minor axis, and the other focus is on the right side of the minor axis. So you have focus 1, focus 2. How to represent the foci is we have to compute the C here first. The C here has the equation C squared equals to A squared minus B squared. And after you find the C, you just add C to get one focus, and you minus C to get the other one. Right? So what does the foci mean? So the foci means that if you have a point in an ellipse, then the distance from this point to the first focus, adding the distance from this point to the other focus, the sum of these two distances are fixed. And the number is 2 times the length of the half axis, which is the length of the major axis. So the sum of these two distance is the same as the major axis here. Right. It makes sense on the first point here, right? Because when these two add up, it's basically you are adding two half axis, which is the full axis here. And same thing as this point here. And we call these 2 point vertices. And as for these 2 points on the minor axis, we call it covertices. Okay. So far, so good. All right. The ellipse has an important uh, application in astronomy. For example, the path that the Earth reruns around the sun is the graph of an ellipse, and the the foci means that that is the position of the sun. Right? You might think of the sun doesn't move and the earth revolves around the sun, but if you take it out of the content and setting at the perspective of the solar system, right, where the sun is not fixed, is actually these two objects reround each other. But because the sun has a greater mass, the sun doesn't move that much. So in this case, the focus, is really, really close to the axis, but it's still an ellipse, right? And you can imagine that the sun, just moves around these two foci, and the Earth is moving around this ellipse. Right? If you have two objects with really similar mass, then this difference would become more obvious. Right? The ellipse would look more flattened. Right? And the bigger objects move around this foci, and the smaller subject move along this ellipse. Okay. So in the case where the y-axis is the major axis, then the graph looks like a stand-up egg. So the longer axis, the major axis, happen on the y-axis. And the smaller axis, the minor axis, occurs on the x-axis. The equations still have the form like this, but in this case, you are dividing bigger number for y squared. Instead of, in the case before, we have a bigger number under x squared. There is a typo here. The foci should be 0 and plus and minus c. So in this case, the two foci are on the y-axis because this is the major axis. So this is C0, sorry, 0C. And this one is 0 minus C. And these 2 points, on the major axis are called vertices. And these 2 points that are on the minor axis are called co-vertices. Okay. And the foci means that the distance between the points to the first focus and the distance between the point to the second focus. When you add these two distances up, you have the fixed length, which is the length of the major axis. So d1 plus d2 equals to 2a. So this is the case where the ellipse is centered at the origin. Right? But you have, in more general cases, the center may not be at the origin. Right? It would move around to another point, let's say h and k. So in this case, the center form would just be a translation, right? You just minus h to x and minus k to y. So basically, you have the vertical and horizontal translations to the graph from the graph of the ellipse that are centered at the origin. Okay. In this case, where the x-axis is the major axis, the graph is still the same, right? Because you just move it, translate it to another position. Right? So in this case, the center is no longer at the center, I'm sorry, the origin. Instead, it has a coordinate h and k. So that means for the vertices, right? Before you have minus c0 and c0 here, but because you translate it to h and k, so you just add h to the x coordinate and add k to the y coordinate. So it becomes h minus c k and h plus c k. Same thing for the covertices on the minor axis. Right? Instead of having oh sorry, this is foci. This should be minus a. This is minus this plus a. So instead of having 0 b, this should be k plus b, and this is k minus b. And as for the two foci, here and here, this one, instead of having a minus c0, you just add h in x and add k to y, becomes h minus c k, and the other focus is h plus c k. Okay, so far so good. Same thing here where the y-axis is the major axis, so you have the graph of a stand-up egg. So the major axis is y and the minor axis is the x here. So you just add h and add k, well, add h to the x coordinate for everything we did in the case where center is in the origin, and add k to the y coordinates there. Again, this is the oh, oh, this is good. This is correct. Sorry. Is is the vertices that is not correct. This is oh, the vertex is correct. Some things is not correct. It's here. It should be h plus and minus b. Okay. Because in this case, the minus axis is on the x-axis, so the covertices are on, well, the it's not on the x-axis, is on the minus axis on the y equals to k. And the major axis is on h equals to h. Because it's no longer centered at the origin, so they are not, the x-axis and y-axis are somewhere else. Okay. Any questions so far? Let's see some examples. So in the first case, we have the vertices and foci that are on the x-axis. Right? So that means this is the case where the center is at the origin, and the major axis is the x-axis. So you have the longer edge on x-axis and shorter edge on the y-axis. Okay. So in this case, you have plus h here, plus a0 here, and minus a0 here. So that means that the length of the major axis 2a is 16, so a is 8. Okay, and the foci has the vertices plus and minus 5. So in this case, the c is 5. Okay, so because you have a and c, so because c squared is equal to the a squared minus b squared, so you just plug in 25 equals to 64 minus b squared, and then you can find out what the b is. So in this case, the b is square root of 64 minus 25 is 39. Okay. So this vertex would be having 0 positive radical 39. And this point has 0 minus square root of 39. And the equation looks like that, x squared divided by, because the major axis is on the x-axis, so you're dividing a larger number, which is 8 squared, plus y squared dividing by the small number b squared, which is 39, equals to 1. Okay. As for the second question, now the vertices are no longer on either x-axis nor y-axis, so that means you have the center not at the origin. So first you have to find out what is the center. So the midpoint between minus 3 and 5 is 1. So the center is at 1, 3. Okay, so that means that the length of the major axis, which is the distance between minus 3, 3 to 5, 3, is 8. So 2a is equals to 8. So a is equal to 4. All right. And from the foci, you know that you can compute the c, which is 2 radical 3. Right? That is the distance between one focus to the center. So that is how you get 2 radical 3. So you have a, you have c, then b squared is equal to a squared minus c squared, which is 4 squared, 16, minus 2 radical 3 squared, which is 12, equals to 4. Okay, so in order to write the standard form, right, because you translate it to the center at 1, 3, so you have x minus 1 square instead of having x squared here, divided by, in this case, the major axis is happens on the x coordinate, right? So divided by 4 square plus y minus 3 square divided by 4 equals to 1. Right? Any questions? Right, so that is on ellipse, and we have some more examples. So for the first one here, the center is at 0, 0. And the major axis is on the x-axis, right? The bigger number on the x square. So the vertices are on the major axis, which is minus 6, 0. You square root the 36, and 6, 0. Then you get a, and then vertices is plus and minus a on x coordinate. And the other two co-vertices are on the y-axis, right? The b square is 4, so b is 2. You have 0, 2, and 0 minus 2. And to calculate the foci, you need to find the c. So c is equal to square root of a square minus b square which is square root of 36 minus 4, square root of 32. All right. So because the foci are on the x-axis, so you just add and subtract the c on the x-coordinate, right? Square root of 32, 0, and minus square root of 32, 0. Of course, you can simplify the square root of 32, right, by pulling a square root of 16 out. Square root of 16 is 4, so 4 radical 2. You can simplify square root of 32 by 4 radical 2. Okay, so that is the center at the origin, but for the next case, you notice that is no longer x squared, no y squared here, so the center shift to 4, 2. And in this case, the a is 36, so it's under the x. So that means the vertices happen on the x-axis before it moves to the new center for 2. So you still have minus 6 here, but instead, because you are shifting to 4, 2, so you add 4 here, right, and 2 here. Right. Same thing for the next vertex, right? Before you move to the center, to the new center at the origin is supposed to be 6, 0, but you're adding 4, so it becomes 4 plus 6 and 2 plus 0. As for the two co-vertices, is the b here, so you're supposed to have 0 radical 2, radical 20. So I use the yellow pen to denote the the foci and the vertices before you move to the center, the new center. This is for the case where the center is at 0, 0. And because it moves to the new center, you have to add 4 and 2 on both the x and y coordinates. And finally, for the foci, you have to find the c here. In this case, the c is the square root of a squared, which is 36, minus b squared, which is 20. You get square root of 16, which is 4. Right. So originally, you should have 40 and minus 40. As the coordinate of two foci, and now you move to 4, 2 to the new center, so you have to add 4 and add 2 for both the x coordinate and y coordinates. So you have 4 plus 4 and 0 plus 2 and 4 minus 4, 0 plus 2. Okay. So far, so good. All right. So for the next one, all right, now you have to perform completing the square for the equation on ellipse. All right. So in this case, we did similar to what we did before. You isolate the x term and y term. So you have the x term here plus y squared plus 2y here, and you have minus 21 on the other side. Okay. Now, in order to complete 4x squared minus 24x, right, remember 8x squared plus bx becomes a times a minus plus, sorry, b over 2a squared, and then you have to subtract b squared over 4a after that. So in this case, b is minus 24 and a is 4. So minus 24 divided by 2 times 4, which is a, you have 3. So this is this. That's a square you are completing 2, right? Because you are adding some number, you have to subtract that back. The number you're subtracting is b squared over 4a, which is 9 hold on. One second. Something wrong here. Oh, sorry. The b square is 24. All right, so 24 squared divided by 16, and then you should get um 36. Mhm. Yeah, it's yeah, 36. All right, so you have to subtract 36 uh in order for you to complete the square. So same thing for y squared plus 2y. It becomes y plus 1 square, right? So but you are adding 1 in order for you to complete the square, so you have to subtract 1 after that. All right. So now you just have to simplify this equation. Okay. Let's write it down here. It becomes 4 times x minus 3 squared plus y plus 1 squared equals to, you're adding 1, you're adding 36 to the other side of the equation, so it becomes 16. Okay. And finally, you have to make the other side 1, so you have to divide it by 16 on both sides of the equation. Remember, in the standard form, the right side of the equation has to be 1. So for the x term, it becomes x minus 3 squared divided by 4, which is 2 squared, plus for the y term, y plus 1 squared divided by 16, which is 4 squared, equals to 1. All right. Now this is at the standard form we have. Then we can have all the information, you know, foci, center, vertices, etc. So for the first thing to identify is the center. Right, minus 3 for x, so it's 3 for the x coordinate, minus 1, right? That is the plus 1. So this is minus 1 for y. Okay. And in terms of the foci, you have to find out what the c is. So c here is square root of a square, which is 4 square, 16, minus the b square, which is 2 square, 4. So it's square root of 12, which is 2 radical 3. So because you are dividing a bigger number on y, right? So the graph is a stand-up egg. The major axis is on here. It's supposed to be y-axis, but you move to the new center, the major axis becomes x equals to 3. So the foci is on 3 plus and minus 2 radical 3. Oh, I'm sorry. You should plus and minus 2 radical 3 to the y coordinate. Sorry. So this should be 3 minus 1 plus or minus 2 radical 3. So this is the foci. And in terms of the vertices is on here and here. So which is 3 plus 3 minus 1 plus and minus the a, which is 4 here. So which is 3, 3, and 3 minus 5. That is the vertices, the 2 vertices on the major axis here. How about the 2 vertices on the minor axis, the slimmer edge, slimmer axis? So in this case, you subtract and plus b, which is 2 on the x coordinates. So 3 plus and minus 2 and minus 1 on the y-axis. This becomes 3 plus 2 is 5, so 5 minus 1. And 3 minus 2 becomes 1, so 1 minus 1. So far, so good. So for this type of question, the important step is to complete the square and get it to the standard form. After you get the standard form, you have all the information you have. You have the vertex, the coordinate for the center, HK, right, by looking here and here. And you have the length and length of the major axis and the minor axis, right, the A and B here. And from there, you can get the foci, which is, finding out the C. C is square root of A squared minus B squared. Right. Then everything just follows. Okay. So far, so good. Okay. So that is for ellipse. Now, finally, you have the last topic is on hyperbola. So hyperbola is something looks like this. It could look like this. Oops. And it could look like this. This is called hyperbola. Yeah, the equation is something like this. Right? They are all centered at the origin. This is the center of the hyperbola. Okay, and so this is for the case here, and this is for the case here. You just just memorize how do you find the foci and how to find the vertices, right? Um, so in this case, the vertices are here and here. I use a different color. So these two are foci. Oh, sorry. These two are vertices. And the foci are the 2 points further from the vertices. So in order to find the foci, the c squared is equal to a squared plus b squared, right? Instead of minus b squared in the case for ellipse. So you notice the sign, the positiveness and negativeness changes, right? Switch, right? You have minus here and plus here. In the ellipse, you have plus here, but minus here. Right? So in the second case, right, you shift the foci, all right, to the other side, to the y-axis. So in this case, the foci is the 2 points here and the point here. And the vertices are on the y-axis here and here. Right. Okay. So let's do some examples. In here, all right, x squared divided by 9, y squared divided by 25. So in this case, the a is 3 and b is 25. All right. So in this case, x squared minus y squared. So the x squared has a positive coefficient. So the vertices and foci are on the x-axis, right? So this is the case where the graph looks something like this. Okay, so the vertices are positive and minus 3, 0. So in terms of the foci, you have to find out what is the number c, which is square root of a squared plus b squared, which is square root of 9 plus 25, which is square root of 34. So it's positive and minus square root of 34, 0. Okay. All right. As for the next question, right, the vertices and foci are on the y-axis, so that means the coefficient for y squared is positive. Right, so in this case, you have y squared and minus x squared. So how about the coefficient? In this case, we have to find out, you already know what is the a, which is 2. So y squared divided by 2 squared right? In terms of B, you have to find out by looking at the foci. So this is C. C is 2 radical 5. So because C squared is equal to A squared plus B squared, you just solve for B squared. So C squared is 20. A squared is 4 plus B squared. So that means B squared has to be 16. So that B is 4. Okay. This is x squared divided by 16. Okay. So as you can notice that A and B no longer have, which one is bigger or which one is smaller. Right. The difference between the two graph is determined by the sign here, right? If the sign goes to is in front of x squared, then the graph looks something like this, and the vertices and foci are all on the y-axis. So in the first case, the sign, the minus sign is in front of y squared. So now everything, vertices and foci are on the x-axis. Right? So far, so good. All right, we have some time left. Let's do some exercise on, let's um, pull out some exercises on lumen 2. So let's do something on the ellipse, on circle, sorry. Okay, so now you have an equation 2x squared plus 2y squared plus 4x plus ay plus 8 equals to 0. I want you to find what is the center and what is the radius. Right, this is a circle. You can notice the coefficient for x squared and for the y squared are the same. So that's why it's a circle. Right? If you finish, then let's do some ellipse. All right, let's go over this. So you have 2x squared plus 2y squared. Oh, wait, wait, what was the question again? 2y squared plus 20x plus 12y minus 4 to the 0. Is it the same question that we have? So 2 should be 2x squared, 2y squared, sorry, 4x, ay, and plus 8. Okay. All right, so first step is to put the x term and together, the y terms together, and put the constant to the other side of the equation. So for the x term, when you complete the square, it becomes x plus 1 square. Okay. To trade off, you have to minus a number 2. Okay. For y, for y, to complete the square, you have plus 2 square here. Right. To trade off, you have to minus 8. Okay. Yeah. So now you just need to put every number to the other side of the equation. You have minus 2, you have minus 8. They all move to the other side. So now you have 2x plus 1 square plus 2y plus 2 square equals to, well, minus 8 plus 8 plus 2. So it's 2. Right. So now the final step is to get rid of this 2 coefficient. You divide it by 2 on both sides of the equation. Now you just have this as your standard form, right? So from this standard form, you know what is the center, which is minus 1 minus 2. And you have the radius, which is the square of 1, 1. Okay? Any questions? All right. And I probably have the ellipse wrong.
Welcome to.
Can someone give me the question for the ellipse? 4x squared plus 16y squared 32x 32y plus 16 equal to 0. Thank you very much. All right, so the strategy is still the same. You put the x together, y together, and then constant to the other side. So you have 4x squared, 32x, 16y, 32y equals to minus 16. So to complete the square for x, it becomes 4x plus 4 square. To trade off, you have to minus 16 times 4, which is 64. Okay, so for y, it becomes 16y plus 1 square. To trade off, you have to minus 16. And the other side is still minus 16. Okay, so the next step is to put these numbers to the other side. So it becomes 4x plus 4 square plus 16y plus 1 square equals to 64. Okay. This is not quite the standard form because the right-hand side is still not 1. So you have to divide it by 64 on both sides of the equation. So you have 4x plus 4 square divided by 64 plus y plus 1 divided by y plus 1 squared, 16y plus 1 squared divided by 64 equals to 1. Okay. 4 divided by 64 is 16, which is 4 square. 16 divided by 64 is 4, which is 2 square. Okay. So now this is the standard form. We're having, and now the final step is to retrieve information from the standard form. So we know that this is not centered at the origin. What is the new center? Well, plus 4 is minus 4. So the center is minus 4 because y plus 2 is y minus 2. So it's minus 2. This is the center. All right. Because the 4 here is bigger than 2 here, right? So the major axis is the x-axis. Well, before it moved to the new center, right? When the center is origin. So this is the A, and this is the B. Okay. Right. When it's from x-axis now to the center to minus 4 minus 2. So this is y equals to minus 2. And the minor axis was the x-axis. Now it moves to minus 4. So x equal to minus 4. So from y-axis to x equal to minus 4. Right. So A is 4, B is 2. Now you can calculate what is the C, which is square root of A squared minus B squared, which is square root of 16 minus 4, which is radical 12 to radical 3. Okay. Right. So now let's find out what are the vertices on the major axis. Basically, you just add and subtract 4 on the um, uh, the, the center for the x coordinates, right? So plus and minus 4 minus 4 minus 2, which is 0 minus 2 and minus a minus 2. As for the minor axis, you just subtract and plus and subtract 2 on the y coordinates, which is minus 4 and minus 4, 0. All right. Since the foci are on the major axis here, the foci should be subtracting and adding and subtracting 2 radical 3 on the x coordinates. So plus and minus 2 radical 3 minus 4 minus 2. Okay. Any questions? So far, so good. Let's do the final exercises on hyperbola. So you have the equation y squared over a squared minus x squared over 15 squared equals to 1. And you find out what are the vertices and foci. All right.
Oh, are you kidding me?
What is going on? Please don't do that. Let's finish this real quick. So for this hyperbola, because um the positive coefficient happens on the y square, so that means the graph looks something like this. Both the vertices and the foci are on the y-axis. Okay, so how do we find the uh, vertices? Right, they are the 0 plus and minus a. In this case, what are the, so in this case, the a here is 8 and b here is 15. Okay, so in this case, the vertices are 0, positive or minus 8. And to find out c is a squared plus b squared. So you have 64 plus 225, which is 289, which is 17 squared. Yeah. Okay, so the foci are 0, positive or minus 17. Okay, any questions? So for hyperbola, the very first step you should do is to identify what is the graph look like, right? So you find out what is the minus sign happens before x squared or before y squared. So in this case, it's before x squared, so everything is on the y-axis, the focus and the vertices. And in the other case, when you have the minus sign before y squared, then everything are on the x-axis, right? Both the vertices are and the foci. Make sense? Okay. Questions? Any questions? Okay. I would try my best to get the exam 3 done during the weekend. So you should have the grade by the end of the weekend, hopefully. Okay. And according to schedule, your exam, the last exam, exam 4, should be on, well, today is 23rd. We are having lecture 22. Then we have 3 more lectures, following by a review session. So the exam should be on May the 12th as scheduled. Okay. Right. If there's no, yeah, it would be on Lumen as well. So same drill. You do the exam on Lumen, you submit your work. Well, I figure it's hard to submit it on Lumen, so I would create a session on Blackboard and then you submit it on Blackboard. Okay. Well, in this time, I figure some of you have trouble uploading on Lumen, so instead you email me. It's fine this time. I really prefer you submit it on Blackboard instead of email me, right? Because if you email me, a lot of cases I will miss it because tons of you emailed me at the same time. So it's hard to keep track of. Um, but if you do it on Blackboard, it's it's there. So no. This is for exam four. Exam three, everything is good. All right, everyone. I got every one of you. So doesn't matter. Okay, if there's no question, you know, free to leave.